All right, so we're rolling along here. Next thing we want to do is get our salary filled in. So very, very, very same approach to this. I'm just going to copy um, the first part of this, and I don't actually need the last part of this. Um, all right, um, and so now we're going to be reading the salary file. Um, we'll assume there's a header inside of there because there is. Yep, salary file. And then we're going to be reading the data. And for the salary, we're just actually worried about one number. But we need to accumulate that number for each team for each year. And that's where we get some interesting map work going on to help us accumulate that number. Um, all right, so let's go figure out our data here. Uh, let's read the file. So we got the tokens. And what we need, what we care about is let's do this, the integer salary amount is going to be tokens, so I'm sorry, integer dot parse int for token sub something. Oops. So which token is that? Well, if we go to salaries here, this is a short one, so we can say the year is 0, the team is 1, the league ID is 2, the player ID is 3, and the salary ID is 4, which makes sense. There's 5 items. So this gets us points to salary as number 5. And then we also need from this the year, um, which is 0. And I think what we need, the other one is the team ID. Um, and so then, yes, so that's going to tie us back to the data we read from the team ID. That's just going to be a string. Oops, int year, and then string team ID is just simply tokens sub 1. So this is going to tie us back to the team, but wait, we actually never saved the team anywhere. We just printed them out. So how do we save the teams to be able to correlate to the the line here? Hmm. Um, oh well, we can use a map, right? So we want to look them up by team ID. Now, again, the most important value of the purpose of a map, and hopefully you've seen this in some other content by now, book, videos, whatever, is a quick lookup. And so we have, a dozen, 100, 1,000 teams. I don't know how many teams there are in the data. And your next data might have millions. So we want to be able to find that team very quickly and add data to it, from these other files. So let's create a map um, of string, which is the team ID, and then team info, right? And so this is team data. New. We can do a tree map this time, just for lack of a. Now notice it fills this in. I'm going to take that out because I don't need it. It'd be redundant. And it actually means if I change the left-hand side, I have to change the right-hand side. And I'll give you a hint. We're going to change the left-hand side here in a minute. All right. So every time we see a team ID, we're going to add the team data inside of there, and we're going to go from there. So instead of printing out the team, here each time. Let's say we're going to add that into the map. So we're going to say team data dot put. So what's the team ID? Well, I actually didn't grab the team ID in the data because I don't need it once I've loaded it in. So now I need to go get the token that was associated with the team ID. And if I go back to my teams, the team ID was the third token, so 012. So token 2, and then we put the team underneath that token. So great. Then we have all their teams. And so then when I get to the salary, well, what I want to do is I want to go get that team, and I want to add in this salary value to the salary that it already has. So I can say my team info is equal to, well, let's go get that team from up above, team data dot get for that team ID. And then I can do team dot get salary. No, I'm sorry, team dot set salary. Team salary is going to be team dot get team salary plus the salary for this player. So it's going to start at 0 and then it will accumulate from there. And then as far as my test goes, I can say return, no, not return, sorry, system.out.println team data. And let's see all the salary for the team that I got. So my code compiles. I've been coding a long time. I tend to write Java pretty cleanly. Let's give it a shot. Everything failed. Index out of bounds exception, 5 out of bounds for length 5. I did salary was 5. I meant to do salary 4. So if you noticed, 0, 1, 2, 3, 4. I did 5. I don't know why. Either a mistake mentally or typed it wrong. I don't remember. Um, it's something's going. Oh, it seems like it's running forever. I can stop my test here. Do you know what I did wrong? Uh, I think it stopped my test here. Um, I forgot to read the line afterwards. As I said, I sometimes forget that, and it's when it runs forever. I immediately know because I forgot that enough times that I didn't do the line. So I guess here, if you forgot it, beforehand, you're out of luck. But if you forgot it now, you got to see it this time here. All right, so there. Now everything's running again, and I'm getting the data. Well, 1884, the team salary is 0 because I don't have data from that. Um, and well, because I have this. Okay. Uh, well, I can't see what's going on. I'd like to see what's going on better. Let me show you another trick inside of here. This is a bit of a hack, but it actually will help um, your yourself a lot in dealing with big data. It might not be what you want to do for your final version, but it's a great way to do it while you're testing. So you have teams that go back to 1871, but I have salary data that only goes back to 1985. So here's what I'm going to do. I'm going to go to my code, and right here, I'm going to say if team.getYear is greater than or equal to 1985, then I'm going to save the team data. Otherwise, I'm just going to throw it out. So that'll shorten my list of stuff, and I'll have everything that's useless data will be out of my way. Again, this might be a problem if I do get that data later on. I'll have to modify my code, but it's a way of me just never dealing with the junk data. All right, so now you can see my first team is Anaheim. And then I can scroll here and see the rest of them. But all of my teams seem to have data. But wait a minute. So that's that's a big number. One, two, three, 1, 2, 3. $468 million in salary. That seems like a lot in 2004. And then when I scroll this way, I think you. I don't know if you saw it when I saw it here, but let me keep going until I find one. Um, so here's the Cubs in 2020. Do we think that they spent 21 billion dollars in salary? That seems a bit high. Um, and there was one of these that actually had negative number, which seems like improbable that they didn't send salary that the players paid them to play. So this isn't quite right. You may or may not have caught this, but it's not quite right. And so it is important to have a sense of the problem to know whether or not you're doing a good job with this or not. You need to check your data to make sure it has logical sense, and that might mean doing the math by hand. In this case, I know exactly what the problem was. I kind of did it on purpose, just to kind of get this sense of it. Just so you got to get past the idea that hey, my code ran, it must be right. Um, in this case, you'll have test cases to tell you, and in almost every case in this class, you'll have test cases to tell you when it's wrong. But it's important to start developing a sense of is my code working correctly on your own? A little bit through intuition and a little bit through intentional checks. So what's wrong? Well, quite simply, uh, the thing that might have set off some bells for you is I went and grabbed um, 3 items out of here from the tokens, and I only used 2 of them. So what I've given you is the total all time every franchise has spent. But I haven't talked about the all time wins or anything else. I don't have the individual years separated out. So the salary is all time, not for the individual teams. And so that's a function of the way I structured my map. My map is actually incorrectly done. And we're going to fix that in the next video. But before you jump onto the next video, I want you to think about why this map of teams is insufficient and see if you can think of a way to be able to get to a map of teams where a team is each year, not the franchise of all time. All right, so take on that challenge and then we'll come back to that in the next video.